Why can a commercial hood have plenty of exhaust airflow and still leak smoke into the kitchen? Watch the plume. A fast horizontal makeup air jet can bend hot, grease-laden vapor past the hood edge before the exhaust ever captures it. More fan is not automatically the cure. Capture is a complete airflow problem. Start with the whole boundary: cooking appliance, rising thermal plume, hood geometry, grease removal device, duct, optional pollution control unit, blower, discharge, and makeup air. Every part changes the installed duty. A catalog fan number by itself cannot describe this system. First, classify the cooking process and the exhaust it creates. Heat and water vapor are not the same design basis as grease-laden vapors or smoke. Hood type, construction, listing, fire protection, and local code requirements are project-specific. Confirm them with the hood supplier and the authority having jurisdiction before selecting the blower. Now look at capture and containment. The plume expands as it rises. Appliance location, hood height and overhang, crossdrafts, open doors and nearby supply diffusers all affect whether the hood edge intercepts it. A good design captures the plume at the source and keeps it inside the hood reservoir through the real cooking cycle. Makeup air replaces exhausted air and helps control building pressure, but its delivery matters. High velocity aimed across the appliance can break capture. Check diffuser position, direction, temperature and interaction with doors and adjacent exhaust systems. Balance the building without pushing contaminants into occupied space. Grease filters are part of the safety and pressure path, not ordinary comfort air filters. Their orientation, velocity distribution, loading and cleaning access affect both capture and resistance. Model the clean and loaded states. If one section loads faster, airflow can migrate and create a weak capture zone. This is a real Longwell backward curved centrifugal fan, shown only to explain physical architecture. It is not a kitchen installation, and the image does not prove suitability for grease exhaust. The final product must meet the project's required listing, construction, motor arrangement, access, drainage, temperature, and fire safety basis. Build the complete pressure path: hood entry, grease filters, duct length, elbows, transitions, dampers, pollution control equipment, discharge fitting, and weather effect. Plot that system resistance against the fan curve. Select the installed operating point, not free air volume, peak efficiency in isolation or motor power alone. Then review the blower as part of the grease exhaust package. Ask where grease can collect, how the wheel and housing are cleaned, whether access is safe, how vibration is monitored, and whether the motor and electrical arrangement match the classified service. Generic ventilation hardware must never be assumed suitable. Controls must preserve capture, not merely command speed. Exhaust operation, cooking operation, and makeup air may require coordinated control under the applicable code and listed system instructions. If variable speed is used, prove capture across the permitted range and define feedback, alarm, fault, and fire system interfaces. Commission the real system under realistic cooking and building conditions. Observe plume capture, measure airflow and static pressure, check door behavior, current, vibration, and sound, and repeat with expected filter loading. Record safe cleaning access and maintenance intervals. Qualified personnel should complete code, fire, and electrical verification. For an engineering review, send the appliance schedule and duty, hood model and geometry, required exhaust airflow, clean and loaded pressure losses, duct route, grease and pollution control devices, discharge arrangement, makeup air plan, voltage, controls, listing and code basis, and cleaning access. That evidence pack is how a centrifugal blower becomes a reliable commercial kitchen exhaust system.